Okay, we're going to have a look at the derivation of the formula that you're going to need to use to solve the radius of your vertical loop. The reason we need to use this formula is because of, well, I'll show you why. For my theoretical roller coaster, my mass was 100 kilos and the starting height was 100 meters, which led to me having a total mechanical energy of 100,000 joules. Okay, yours may be more or less than that, but anyway. So if, for example, that I wanted to choose, if I wanted to find the velocity at a height of 60 meters, so let's say I'm thinking of making my vertical loop 60 meters, then the total mechanical energy is equal to the kinetic plus potential, which means that the total mechanical energy is equal to kinetic energy is half mv squared and potential is mgh. So I put my number in, I put in 100,000, half times by my mass, which is 100, times by v squared, which is what I'm trying to find, plus mass, which is 100, times by g, which is 10, times by my height, which is 60. So 100,000 is equal to 50 v squared, plus 100 times 10 is 1,000, times 60 is 60,000. Subtract 60,000 from both sides gives me 40,000 over here, and 50 v squared over here. We divide both sides by 50. 40,000 divided by 50 is 800, and the square root of 800 is 28.3, and that's meters per second. Okay, so that's the velocity of my cart at 60 meters in height. Okay, fine. So now to find the radius of the loop, because bearing in mind the reason we're doing this is because we want our riders to feel apparent weightlessness at the top here. And so this is the formula that helps us out with that. So 28.3 equals the square root of the radius times by g, which is 10. So to get rid of this square root, we'll square both sides. The square of 28.3 is 800. 800 equals 10r. Divide both sides by 10. Divide that by 10. We have r equals 80 meters. So now we can quite clearly see that a radius of 80 meters is required for the speed that my roller coaster is going to have at 60 meters. And my starting height was 100 meters, so that means my radius is 160. So it completely does not work. And this is where we need to roll this formula and this formula together so we can, if you like, solve for velocity simultaneously. Okay, so let's take the next step now. Going back to these formulas, mechanical energy equals kinetic, which is half mv squared, plus potential, which is mgh, and our other one is v equals the square root of rg. What we can do is we can substitute the value for velocity here into here, and what that's going to give us, and just fortuitously, v squared is what we need to substitute in, so we need to square both sides, v squared, and which tidies this up to just rg, which is nice. So the sum of mechanical energy is going to be equal to a half times by the mass times by rg. Okay, so we're substituting our new term for velocity, times by mgh. Okay, so our mechanical energy is known, half is a half, mass we know, radius we don't, gravity we do, mass we do, gravity we do, height we don't. So we end up with two unknowns, our radius here and our height here. And with just a little bit of thought, we can see the relationship between radius and height. Okay, I probably should have drawn radius vertically like this, and it's clear to see that height is equal to 2 times the radius because it's vertical. So that means we can rewrite this to get rid of another variable. Mechanical energy equals a half mRg plus mg to r. Now that is the formula that you all need to use to determine the height or the radius of your vertical loop. So everyone starts with this formula here and substitutes in their own numbers. So for example, for mine, 100,000 joules is equal to a half times by the mass, which is 100, times by the radius, which is our unknown, times by g, which is 10. Get some brackets around this so I don't make mistakes. 100 times by 10 times by 2 times by r. 100,000 equals a half times 100 is 50. 50 times by 10 is 5. Half times 100 is 50. 50 times by 10 is 500. R plus 10. 100 times by 10 is 1,000. Times by 2 is 2,000. R. So 100,000 equals 2,500. R. We divide both sides by 2,500. 2,500. And we have R equals 40 meters. So for me, that is my crucial information for my vertical loop, that my R is equal to 40 meters, and so obviously the height of my vertical loop is 80 meters. Okay, so that's the formula you need to use to plug in to find the height of your vertical loop.